Good day everyone, my name is Ray Bahanting Flores and welcome back to my YouTube channel. For today, we will discuss about indefinite integrals. And the objectives of this video is that the learners are now able to be familiarized with the properties of the indefinite integrals and use it in finding the definite integral of some functions. But before we proceed, let us give some statements or definition that best describe about definite integral. So definite integral is the difference between the values of the integral of a given function f of x for an upper value b and a lower value a of the independent value of x. So for us to expand about our knowledge about this given definition here about definite integral, let us explore the properties of definite integrals instead. So the properties are: first property, the integral of f of x dx from a to b is equal to 0. Again, the integral of f of x dx from a to a is equal to 0. Number 2, the integral of c f of x dx from a to b is equal to c, the integral of f of x dx from a to b for any real constant c. Next is the integral of f of x plus minus g of x dx from a to b is equal to the integral of f of x dx from a to b plus minus the integral of g of x dx from a to b. Next is we have the integral of again, the integral of f of x dx from a to a is equal to the integral of f of x dx from a to c dx plus the integral of f of x dx from c to b for any real numbers. So for us to apply and understand the given definition about definite integrals, which is it is the difference, so let us apply it to examples. But first, let us explore about this fundamental theorem of calculus, which is that let f be continuous on the interval a b and let f be any antiderivative of f. Then we came up with the integral of f of x dx from a to b is equal to capital F b minus capital F a, which is equal to f of x from a to b. So for us to apply the fundamental theorem of calculus and considering the properties of definite integrals with the definition itself about definite integrals, so let us explore it through the given examples here. So first is we came up this first example. Find 4t raised to the power of 3 from 1 to 2 dt. First is we came up with excluding the constant, which is c, and then we apply the as you remember in a definite integral, we apply those property number 3, which is we came up with adding 1 to the exponent of our value of our variable. So we came up with for the integral of t raised to the power of 3 plus 1 all over 3 plus 1 from 1 to 2. So we came up with 4 raised to the power of 4. Again, we came up with t raised to the power of 4, since if we multiply 4 to 3, again, if we multiply 4 to t raised to 4 all over 4, we came up with t raised to 4, since 4 divided by 4 is equal to 0, is equal to 1. So we came up with t raised to 4 as the remaining value from 1 to 2. So in this situation, just substitute the 1 and the 2 to our variable, which is t. So we came up with 2 raised to 4 minus 1 raised to 4. As you remember the fundamental theorem of calculus of f b minus f a, our a here is 1 and our b here is 2. So 2 raised to 4 minus 1 raised to 4, and that will be equal to 15 as the definite integral of this given example here, number 1, which is the integral of 40 cubed from 1 to 3 dt. So next is we have this given example, quantity of 6x squared minus 3x plus 5 dx from 2 to 5. Again, the formula, as you observe, we just exclude the given the constant, and then we apply the property, which is to distribute the integral signs as you observe here. So we came up with 6 integral of x squared dx from 2 to 5 minus 3 integral of x dx from 2 to 5 plus 5 the integral of dx from 2 to 5. Next is just we solve it and find the values. So here we came up with 2x squared no, it is 2x cubed, and then 2x cubed, sorry, it is 2x cubed, and then from 2 to 5 minus 3x squared all over 2 from 2 to 5 plus 5x from 2 to 5. Next is we came up with 2, 5, 3 or cube minus 2 cube for our first equation. Next is we came up with negative 3 all over 2, quantity of 5 squared minus 2x squared plus 5, quantity of 5 minus 2. Again, we have this is cube, again this is cube, and this is squared here, and here is cube. I am very sorry for that mistakes. So we came up with, again, we have this 2 quantity of 5 cube minus 2 cube minus 3 over 2 quantity of 5 squared minus 5 squared plus 5 quantity of 5 minus 2. And if we simplify that, we came up with 234 minus 63 all over 2 plus 15. And if we simplify that values, we came up with 435 all over 2 as the definite integral of the given example or the given function here for example number 2. Next is we have this example number 3. How about find the integral of 1 over y dy from 1 to 2. So as you remember the format, 1 over y is equal to ln, absolute value of y, from 1 to 2. So just substitute. So we came up with ln 2 minus ln 1, and that gives us the value of approximately 0.69,931 minus 0, and that gives us the definite integral of 0.6931 as the definite integral of this given function here in example number 3. Example number 4. Find the area of the region between the x-axis and the graph of f of x is equal to x squared minus 4 from x, which is equal to 0, to x, which is equal to 2. So if we rewrite the given problem into an equation, so we came up with the integral of x squared minus 4 dx from 0 to 2 is equal to x cubed all over 3 minus 4x from 0 to 1, from 0 to 2. And if we solve that, just substitute the value of 0 and 2 to our given, which is x cubed all over 3 minus 4x. So we came up with 2 cubed all over 3 minus 4 multiplied by 2 minus the quantity of 0 cubed all over 3 minus 4 multiplied by 0. So we came up with negative 16 all over 3. And since we are finding the area here, so we need to absolute the value which is negative, absolute value of negative 16 all over 3. And we came up as the final answer, or the definite, or the area, considering the definite integrals, which is equal to 16 all over 3 units squared, since we are asked to find the area between the x-axis or the regions. And that would be all for today's video. Please do subscribe if you haven't done subscribing, and please do click the notification bell for you to be updated. And again, I just want to give credits to our professor or instructor, Sir Mateo Cañeda, for the learning materials that serves as my basis for making this video. Thank you and God bless.